Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrow's Algebra 1 and 2 class. Today we're going to discuss the properties of real numbers and some conversions. So it's going to be a good day, easy day, but very important. A lot of times my students feel that these properties are just not that important, that they're just words to trick you. But no, it's really, really crucial that you know these properties because it's going to help you become a better mathematician. So please pay attention and try to really pay close attention to the detail so you can understand these properties. So let's get started. As far as the properties of real numbers go, let A, B, and C be real numbers, variables, or algebraic expressions. Okay, so every letter A, B, and C that you see today in this lesson, that represents real numbers, variables, and or algebraic expressions. So number one, the commutative property of addition. The commutative property of addition states that A plus B equals B plus A. What that is simply saying is you can change the order of an addition problem without changing the sum. For example, 3 plus 4 equals 7. Well, so does 4 plus 3. That equals 7. So 3 plus 4 equals 4 plus 3. They both equal 7. So that is a wonderful example of a commutative property of addition, which allows you to change the order of addition problems without changing the sum. Number two, the commutative property of multiplication is very similar. The commutative property of multiplication states that A times B equals B times A. So you can change the order of a multiplication problem without changing the product. For example, if I have 3 times 4, that equals 12. Well, what does 4 times 3 equal? That also equals 12. So being that 3 times 4 equals 4 times 3, they both equal 12. That's an example of the commutative property of multiplication. You can change the order of a multiplication problem without changing the product. Number three, the associative property of addition. The associative property of addition is similar to that of the commutative property, but there is a big difference, so please pay attention. The associative property of addition states that A plus parentheses B plus C close parentheses equals parentheses A plus B close parentheses plus C. If you notice here, you may just think, oh, they're changing the order again. Well, yes and no. They are changing the order of an addition problem, which is totally valid. However, if you really notice, what's happening is that if you notice the A here, it was on the outside. It got brought into the parentheses. And if you notice, the C was inside the parentheses and it got brought outside of the parentheses. So the associative property is activated when you pull something out of the parentheses and replace it with another value. For example, 3 plus parentheses 4 plus 5 equals 3 plus 5 plus 4. Well, look at what happened here. The 3 which was outside is now inside the parentheses, and the 4 which was inside the parentheses is now outside of the parentheses. So I took something out of the parentheses, in this case I took the 4 out, and I replaced it with another value, which in this case was the 3. So that's the associative property. Now, please be careful. This happens a lot, and my students tend to make mistakes here. So what if I gave you 5 plus 6 plus 8, and I said that equals 5 plus 8 plus 6. This here would be the commutative property of addition. Why commutative, you may ask? Well, if you notice, did I take anything out of the parentheses? The answer is no. All I did was I switched the order of 6 plus 8 to 8 plus 6. So that's commutative property, okay? So again, to get the associative property, you must take something out of the parentheses and replace it with another value. Number 4, the associative property of multiplication, almost identical to the associative property of addition, except it's dealing with multiplication. So for the associative property of multiplication, it states that A times parentheses B times C equals parentheses A times B plus parentheses plus, times C. For example, if I have 3 times parentheses 4 times 5, close parentheses, equals parentheses 3 times 5, close parentheses, times 4, that is the associative property of multiplication. Why? Well, I took the 3 which was on the outside and I placed it inside the parentheses, and I took the 4 that was inside the parentheses and I took it out of the parentheses. So again, the associative property of multiplication is just like that of addition. You must replace or take something out of a parentheses and replace it with another value. This A, which is outside, is now inside the parentheses, and this C, which was inside, is now outside the parentheses. And that's the associative property of multiplication. The distributive property of multiplication. Before I show that to you, let's just think about what the word distribute means. If I tell you to distribute the following papers to all of your classmates, doesn't that mean that you're going to literally pass out or hand out or give every single student the paper? I hope that makes sense, because that's what distributive property of multiplication is in essence. What's happening here is I have A times parentheses B plus C, and that A is going to be distributed or multiplied to every single value inside of the parentheses. This is a basic distributive property, but I can have 4, 5, 6, 10 terms inside the parentheses, and that outside value, whether it be a number or a variable, must be distributed or multiplied to every single term inside. So A times B is AB, A times C is AC, and there's a plus in the middle because they are being added. Sometimes when I put, or not me, when a test has a value on the right side of the parentheses, sometimes people get a little bit confused, but please don't. All this is saying is F is being distributed. So I'm going to multiply F to everything inside of the parentheses. F times D is FD plus F times E is FE. For example, 2 times parentheses 3 plus 4. Well, this 2 is going to be distributed 2 times 3 plus 2 times 4, which equals 6 plus 8, which is 14. How about this next one? Parentheses 5 plus 3, close parentheses, times 2. The 2 will be distributed to everything inside of the parentheses. 2 times 5 and 2 times 3. Okay, they're being added. So I have here 10 plus 6, which is 16. The identity property of addition. When we look at identity properties for both addition and subtraction, what I try to have you picture is you in front of the mirror. When you look at yourself in the mirror, you see yourself, right? That is your identity. So think about that concept, but let's apply it to numbers. What number would I add to anything else to get itself? Okay, what number would I add to any number to show its own identity? Hopefully you're thinking of 0, because the identity property of addition states that A plus 0 equals A. In other words, anything plus 0 is itself. For example, 5 plus 0 equals 5. Okay? So the identity property of addition, very important. We also have the identity property of multiplication. Same concept. What number times another number gives itself? Sorry about that. Okay, so the identity property of multiplication, what number times another number gives you the same value? Okay, what number times anything gives its identity? Hopefully you're thinking of 1, because that is exactly what the identity property of multiplication states. It states that A times 1 equals A. So in other words, any number times 1 is itself. For example, 5 times 1 is 5. Okay, so any number times 1 is itself. Okay, the additive inverse property, this we've already seen, but I want to make sure that I give you a nice, complete, concise, detailed list of all of the properties of real numbers. So the additive inverse property, if you remember, states that a plus a negative a equals 0. In other words, any number plus its opposite equals 0. For example, 8 plus a negative 8 equals 0. All right, so any number plus its opposite equals 0. The multiplicative inverse property. Well, the multiplicative inverse property, which we've seen as well, states that a times 1 over a equals 1. So in other words, any number times its reciprocal equals 1. So for example, 3 times 1/3 equals 1. Any number times its reciprocal equals 1. The zero property of multiplication, okay? Sometimes it's known as the zero product property. The zero property of multiplication simply states that anything times 0 is itself. So a times 0 is 0. Anything times 0 is itself. For example, 6 times 0 equals 0. Now the closure property of addition. Closure is pretty simple, but I still like to mention it. The closure property states that a plus b will equal a real number. Remember what we said, that a and b represent real numbers, variables, or expressions. So when you're adding real numbers, you're going to get a real number answer. Okay, for example, 3 plus 5 equals 8. 3 is a real number, 5 is a real number, 8 is the sum of real numbers. It has to be a real number. And the closure property of multiplication states the same thing, but in multiplication form. And it states that a times b equals a real number, where a and b are real numbers. For example, 4 times 2 equals 8. All right, so those are the properties. Now, let's continue. Conversions in the English system. I know that you've seen this a lot, but I also know that a lot of times people forget. These conversions are very important, and hopefully I'm going to make this real easy for you. So let's look at the different conversions of the English system. And the first one we're going to look at is weight. And please remember that 16 ounces equals 1 pound. 2,000 pounds equals 1 ton. As far as distance goes, 12 inches equals 1 foot. 3 feet equals 1 yard. 36 inches also equals 1 yard. And if you think about that, since I have 12 inches in a foot, okay, and 1 yard is 3 feet, well, 12 inches times 3 feet is 36 inches. 36 inches are in 1 yard. 5,280 feet equals 1 mile. 1,760 yards also equals 1 mile. Why would that be? Because remember that there's 3 feet in every yard. So if you go ahead and divide 5,280 by 3, you're going to get 1,760 yards. Okay, capacity or volume. 8 fluid ounces equals, sorry about that, 8 fluid ounces equals 1 cup. 2 cups equals 1 pint. Okay? Now, I like to do this extra step, so please pay attention. Sometimes they're going to ask you for how many fluid ounces in a pint, and that's pretty easy. Think about it this way. There's 8 fluid ounces in 1 cup, but there's 2 cups in a pint. So 2 times 8 would be 16. We got 16 fluid ounces equals 1 pint. 2 pints equals 1 quart. By the same logic, if there's 16 ounces in 1 pint, and there's 2 pints in 1 quart, that means that there are 32 fluid ounces in 1 quart. And in 4 quarts, you have 1 gallon. Same logic with the ounces. If there are 32 fluid ounces in 1 quart, but there are 4 quarts in a gallon, then you're going to have 128 fluid ounces in a gallon. Time. 12 months, of course, equals 1 year. 52 weeks equals 1 year. 365 days equals 1 year. 7 days equals 1 week. 24 hours equals 1 day. 60 minutes equals 1 hour. 60 seconds equals 1 minute. And since there are 60 seconds in every minute, 60 times 60, there are 3,600 seconds in 1 hour. So this table is definitely something that you want to memorize. If you need to pause and rewatch it and rewrite it, please do so. Make sure that this table is something that you know, not just memorize for a test, but that you learn it. Now, once you've learned the conversion rates, let's talk about the actual conversion. And the easiest way to convert between measurements for me is to remember the following. Number 1, when going from a large unit to a smaller unit of measurement, multiply by the conversion rate. What is he talking about? Look at it, or rather think about it in terms of feet and inches. Okay? We know that there's 12 inches in a foot. So I'm telling you that if I'm going from a larger unit to a smaller unit, you multiply. Always use feet and inches to remind yourself. Okay? If I have 1 foot, how many inches would that be? Well, we know that there's 12 inches in every foot, so 12 times 1 equals 12, and that's 12 inches. Let's say I have 5 feet. How many inches would that be? Well, since there's 12 inches in every foot, I'm going from large to small. I'm going to multiply 5 times 12, which would equal 60 inches. So when I'm going from a large unit to smaller units, please remember to multiply. It sounds counterintuitive because I'm going from larger to smaller, but that's exactly the way it is. How about when we're going from a smaller unit to a larger unit? When we're going from a smaller to larger unit of measurement, we're going to divide by the conversion rate. Once again, use feet and inches to help remind yourself. We know that there's 12 inches in a foot. So what if I tell you I have 12 inches? I want to know how many feet there are. Well, I'm going from small to large, so I'm going to divide by the conversion rate. Since I know there are 12 inches in a foot, 12 divided by 12 gives me 1 foot. Or let's say I have 96 inches. And I want to know how many feet there are. Well, I'm going from small to large, so I'm going to divide by the conversion rate of 12, and 96 divided by 12 would be 8 feet. And that's how we convert. Okay? Pretty simple. Now let's do a little bit of practice. Let's convert each measurement. I have 46 yards and I want to turn them into inches. Well, first of all, always know your facts. And the fact here is that 36 inches equals 1 yard. So clearly yards are larger than inches. So if I'm going from large to small, I am going to divide. So 46 divided by the fact that there are 36 inches in every yard will give me, I'm sorry, I'm wrong. I'm going from large to small, so I must multiply. See what happens when you don't pay attention? You must multiply. So I have 46 yards, and there's 36 inches in each yard. So I'm going to multiply because I'm going from large to small, and 46 times 36 will be 1,656 inches. So again, I apologize about my mistake. That was my bad, and I should pay attention. I'm going from 46 yards to inches. I'm going from large to small, so I must multiply. B, 78 ounces to pounds. Well, remember the fact. There are 16 ounces in 1 pound. So clearly, pounds are larger than ounces. Ounces are smaller than pounds. So I'm going from small to large. So here I am going to divide because I'm going from small to large. So I have 78 ounces, which is my small, and I'm going to large. So I'm going to divide by 16, and that will give me 4.875 pounds. Okay? Because I'm going from small to large, so I divide. 4.5 hours equals how many minutes? I'm going from large to small here, right? And there are 60 minutes in 1 hour. So since I'm going from large to small, I'm going to multiply 4.5 times 60, and that will give me 270 minutes. 86 inches equals how many feet? In this case, again, we're going from small to large, so we are going to divide. Remember that there are 12 inches in 1 foot. I have 86 inches. I want to know how many feet that is. So I am going to take 86 and I'm going to divide it by 12. Why? Because I'm going from small to large. And that will equal 7 1/6. Right? Because 7 times 12 is 84. I have 2 left over. We could reduce it to 7 1/6 feet. Always label your units, especially in conversions. All right, let's take a look at some properties now. Which property does the equation illustrate? Okay, so I have negative 2/3 times negative 3/2 equals 1. Well, to me, that reminds me of the multiplicative inverse. Any number times its reciprocal equals 1. So that would be the inverse property of multiplication, or the multiplicative inverse. Number 2, I got 2 times 3 in parentheses times 5 equals 3 times 2 in parentheses times 5. Most people are going to immediately say associative because they see parentheses. Hopefully, my students will not fall for that trap. If you notice here, 2 times 3 is simply changed in order to 3 times 2. But did I take anything out of the parentheses? No. So this is not associative. This is simply, this is wrong. This is commutative. My bad. This is the commutative property of multiplication. Again, it's commutative because the order changed. I did not take anything out of the parentheses. So it is not associative, it is commutative. Number 3, we got 3 times parentheses f plus r plus 13 equals 3f plus 3r plus 13. I see this as I multiplied 3 to the f and to the r, and then I just added the 13. Well, this part right here is a very clear example of me distributing that 3, so that is the distributive property of multiplication. D, I've got 3 plus 8 plus 9 equals 9 plus 8 in parentheses plus 3. If you notice here, I took a 3 out of my parentheses, okay, and I put the 9, which was outside of the parentheses, and it's now inside the parentheses. So that means I took something out of the parentheses and replaced it with something else, and that is the associative property of addition. Now, let's use properties of real numbers to show that a plus parentheses 4 plus a negative a, close parentheses, actually equals 4. Well, let's think about this. I got a plus parentheses 4 plus negative a in parentheses, close parentheses. I'm going to rewrite this as a plus parentheses negative a plus 3. all I did was switch around the answers here. And this should be a 4. Let me pause real quick. Okay, I apologize about that. Let's start again. I've got a plus parentheses, 4 plus a negative a close parentheses. I'm going to first rewrite that as a plus parentheses negative a plus 4. All I did was switch the order of this addition problem, okay? And that is a fine example of the commutative property of addition. Now, I went ahead and brought this outside a into this parentheses. So there I have the associative property of addition. Again, I brought something into the parentheses, okay? Then a plus a negative a equals 0. And then I have 0 plus 4 left over. Well, this a plus a negative a, I took a number and added it to its opposite, and I got 0. And that, of course, is the additive inverse property, or the inverse property of addition. And last but not least, 0 is a real number and 4 is a real number. 0 plus 4 is 4. So two things could have happened here. You could have named this as simply closure, because the sum of two real numbers is a real number. But I also would have accepted closure slash identity property of addition. Because if you remember, anything plus 0 is itself. Okay? Well, I hope you understood. Hope you learned a lot. Thank you so very much and have a great day. Bye-bye now.